All right, we're going to classifying this reaction. We're going to write the reaction, the full equation, and balance it. And we're given the products. So let's start with that. There's our reaction arrow. Hydrogen is diatomic. It's a gas, and bromine is bromine is also a diatomic element. It's normally a liquid, but I'm going to fill that in a minute, because I noticed that it's a decomposition reaction. Not all decomposition reactions require heat, but this one I know that it does. You're not on the hook to just memorize that, um, but this is going to decompose from hydrogen bromide, which is one of the hydrogen halides. That means hydrogen bonded to a halogen. By the way, the Lewis structure would look like this. It's a polar um, it's a polar molecule. The electronegativity difference is slightly less than 1. It would suggest that it's a polar molecule, which it is. And the characteristics is much like a covalent molecule rather than ionic compound. It has a low boiling point. It's a gas at it's a gas at room temperature. Now this can also be dissolved in water to form hydrobromic acid, which is a strong acid. And again, you're not on the hook to know any of this. We really just want you to know that it's HBr and not. And actually, I don't know why this question is in chapter 11. Why it's and not H2 Br2. In other words, bring these subscripts over. So that's a common mistake students make, right? So that's wrong. We know that all the hydrogen halides are H and then one of the halogens. All right, now bromine, again, back to that, is normally a liquid at room temperature, or what am I saying? Normally, it's a liquid, but because this reaction requires heat, it's going to be produced as a gas. All right, let's balance this. Notice that there's two hydrogens on the product side and two bromines, and one on the reactant side. So we're just going to put a coefficient of 2 to balance that equation. So there is your balanced decomposition reaction for the decomposition of hydrogen bromide.